Okay, problem 3.6.17. We've got a cubic equation here, and we're supposed to find the complex zeros. So that means complex means it has like the imaginary number part to it. So hopefully there's at least one real number in that. So we'll divide that out, have a quadratic left, and then we can use the quadratic formula on that, for example, to find what it would be with the complex part, with the square root of the negative number in there. And then we're supposed to simplify it, use a comma to separate them in terms of I for when we enter our answer. So the first thing is, if you wanted to use the old-fashioned method called the rational root theorem, where you take all the factors of negative 39. So I mean, that would be like 3 and 13 and 1 and 39, and then you take all, and you have to use all of those. So let's just say, let's talk about 3, and put them over the factors of the 4. So it could be a 4, it could be a 2, and it could be the positive or the negative. And then you have to divide that out to find which one is the real number, to find it and then get the quadratic. That's in the old days before computers and higher powered calculators like the graphing calculators. That's the method that would have had to have been used. I really don't see you needing to do that. If I were you, I would say go over and jump over to either your graphing calculator, or I'm going to demonstrate it with Desmos. I went ahead and already typed in your equation just to save us some time. And you just click on here, and it's going to tell you the 0.696 is the one that would work. Well, somehow you're going to have to calculate or, convert that back into a fraction, this 0.696. The way I do it is I go to my graphing calculator, I type in 0.696, then on my calculator, they hit the math button, and the top option is convert to a fraction. And mine says that that's like 87 over 125. So my answer, 87 over 125, is what gives me one of my real solutions. Well, then let's see what we have to do with that. So I'm going to go back to our problem. Again, 87 over 125. Ooh, that's kind of gross. How would I have had to have gotten that with doing it by hand? 87 over 125. That's what x would equal to make it equal 0. Well, for one of my intercepts. So then we multiply by 125 to get that out of there. So that gives me 125x equals my 87, and then I subtract the 87 to the other side. So 125x minus 87, that's one of my factors. The other thing that I have to do with that then is to figure out what's left after I take that out of there. Man, that's gross. So my decimal, again, I could work with that, the 0.696, and then the coefficients, the 4, the 3, I'm going to do synthetic division here if you didn't follow along that's where I was going. So then after we take out the 1, 0 that we know, let's see what we have left here. So that's where you bring down. This better give me a remainder of 0 here. Otherwise, I must have made a mistake when I typed it in Desmos or something. So the 0.696, I'm on a calculator here, times my 4, that gives me 2.784. And then I add my 3 onto that, so I got the 5.784, times again the 0.696, and that's like 4.025664, and then add that to the negative 52, and that gives me negative 47.974336. Now I'm going to multiply that times the 0.696. Hopefully that's a positive 39. Point And it is not. That makes me think, did I type something in wrong in Desmos to start with here? Add 4x squared plus 3, or 4x cubed plus 3x squared minus 52x minus 39 is my problem there. If I get rid of some of the writing that I covered it up with. 4x cubed plus 3x squared minus 52x minus 39. What did I have? 4x cubed plus 3x squared. Oh, minus 52x. Let's see, now we've got a whole lot nicer set of numbers for it, but now it looks like we've got 3 real ones. So we've got that one, a negative that one, and this one. So where it said use imaginaries, it looks like we have 3 real ones. 4x cubed plus 3x squared minus 52x minus 39. And again, those 3 zeros that I came up with was negative 3.606, negative 0.75, and 3.606. You know, I really like leaving places where I make a mistake in there, but don't give up. Notice that I came back, checked my work, looked for what else it could have been, and then let's go see what we're going to have to do with this now, though. So I've got those 3 zeros. I'm back to my problem here. All of this is for naught, because I had that one wrong little thing there. What I'm going to do here is start by, we have the negative 0.75. That does make better sense here, because if you notice these numbers, whoops, hello, that these numbers that I even was talking about here, there's a negative 0.75 right there. So if I said negative x equals negative 3/4, that's 0.75, right? So what is this as a factor if I were going to write it as a factor? When you're doing factors, you can't have fractions in there. So we would get rid of it by multiplying by that 4. And that would give us 4x equals negative 3, and then add the 3 to the other side. So my factor would look like 4x plus 3. And then if we want to see what's left after we take that out, I'm going to just use long division on this one even. 4x plus 3 is the factor, and we got to take it out of this 4x cubed plus 3x squared minus your 52x minus your 39, and let's see what the other quadratic is that remains after that. So 4x times what makes 4x cubed, and I would say x squared. X squared times the 4x cubed, remember, long division, that's our goal, is to get rid of this leading term. And then also x squared times this 3 would give me a 3x squared, right? Well, that's interesting, because that means that whole part's going to go away right now. So after I take this out, what remains, because I've made x squared times that's 4x cubed, x squared times that's 3x squared. I've got exactly, all I have left is this negative 52x minus 39. Well, if that's, so then I have to ask myself, 4x times what makes negative 52? 4x times, I think that's 13, 12. Yeah, so 13, and now we need a negative, so it's a negative 13. Negative 13 times 4, is that not my 52 that I was after? So my 13 times this 4, negative, makes my negative 52x. And my negative 13 times that 3 is going to make negative 13 times 3 is a negative 39. And that's exactly what I needed. So my other factor, so I've got 4x plus 3, and it's times x squared minus 13. We don't need to use an I here because we're not going to have an I in here. It says simplify your answer, use commas to separate. Find the complex zeros. Oh, complex. So we're not going to have an imaginary number. But one of my zeros was the negative 3/4 from here. But then when does x squared minus 13 equals 0? If you add the 13 to the other side, you're going to have x squared equals 13. And then when you square root both sides, don't forget to do what? Put a plus or minus in front. So my other two zeros would be a negative square root of 13 and a positive. You don't need that plus sign in front of it. You can leave that out. Square root of 13. And those would be my three solutions for that problem. If I were going to, the reason I jumped over here to this long division method there instead of synthetic is using that negative 3/4 felt to me like it was going to be a little bit gross, but we could try it quick here. Negative 3/4, and then we have my 4, 3, negative 52, and the negative 39. If you were wanting to use synthetic here, there's just something sometimes that is a little interesting here that happens. So in this case, we would have brought our 4 down, right, for our first step. 3/4 times that 4, the 4's would cancel, leaving me a negative 3, add down 0. 3/4 times that would be 0, negative 52. 3/4 times that negative 52 would be a positive. It's going to come out to your 39. Remainder is 0. Now, here's the interesting part. See how over here when we actually divided it out, we were supposed to get the x squared minus 13? Well, it's here, but because we were dividing by 4 here, our answer down at this step is 4 times bigger than it's supposed to be. So to find out what the factor really is at this point, whenever you're doing this where it's dividing by a fraction up here, your final answer here all has to be divided by that denominator. So there's your x squared, and there's your minus 13 right there for the other factor. And so I wanted to show you the long division method and to convince you then over here what you would have to do. But that's only when you have a fraction out in front of here, that your answer down here, because you're dividing by 4 times or less, or 1/4 of what you really are talking about in the problem. So problem 3.6.17, again, find the complex zeros is what they were asking for in the problem. So repeat any zeros if their multiplicity is greater than 1. We did not have that. But our complex zeros, complex implies imaginary. We didn't have any. But if we were to list all of the zeros, we would have had the negative 0.75 and the negative square root. I think the abbreviation for that, if you're typing it in, is just squirt, SQRT, of 13 like that. Otherwise, you can use, they'll give you that menu where you can actually get the square root symbol. And then the other one, the square root of 13. So whether you do like that or like this, that would be our 3 zeros for that problem.